Hello and welcome to the session. In this session, first we are going to discuss horizontal and vertical lines. Now, the equation of the horizontal line having distance A from the x-axis is either y equal to a or y equal to minus a, and here the choice of the sign will depend upon the position of the line according as the line is above or below the x-axis. And the equation of vertical line having distance b from the y-axis is either x equal to b or x equal to minus b. And here also the choice of the sign will depend upon the position of the line according as the line is to the left or to the right of the y-axis. Now we shall discuss the point slope form. Suppose that we have a point P0 with coordinates x0, y0, which is a fixed point on the non-vertical line L, whose slope is m, that is, slope of line L is m, and let P with coordinates xy be any arbitrary point on the line L. Then we have point xy lies on the line with slope m, and through the fixed point x0, y0 if and only if its coordinates satisfy the equation y minus y0 is equal to m into x minus x0. This is the point slope form of the equation of a line. Let's try and find the equation of a line passing through the point P with coordinates 4, 3 and having slope say m equal to 2. So from here we have x0 is equal to 4 and y0 is equal to 3. So we get the required point slope form of the equation of the line is given by y minus y0 equal to m into x minus x0, that is 2x minus y minus 5 is equal to 0 is the required equation of the line in point slope form. Next we have two-point form of the equation of a line. Let this line L passes through two given points P1 and P2. P1 has coordinates x1, y1 and P2 has coordinates x2, y2. Let point P with coordinates xy be any general point on the line L. Then we have equation of a line passing through the points P1 with coordinates x1, y1 and P2 with coordinates x2, y2 is given by y minus y1 equal to y2 minus y1 upon x2 minus x1 into x minus x1. Let's try and find out the equation of a line passing through the points. Let it be point P1 with coordinates minus 1, 1 and point P2 with coordinates 2, minus 4. So we have from here x1 is -1 and y1 is 1, and from here we have x2 is 2 and y2 is -4. So the required equation of the line is given by y minus y1 equal to y2 minus y1 upon x2 minus x1 into x minus x1. That is, we have y minus 1 equal to minus 5 upon 3 into x plus 1. So we get 5x plus 3y plus 2 equal to 0 is the required equation of the line. Next is slope-intercept form. Suppose that we have a line L with slope m and y-intercept is c. Then we have point xy on the line with slope m and y-intercept c lies on the line if and only if y is equal to mx plus c, and value of this intercept c will be positive or negative according as the intercept is made on the positive or negative side of the y-axis respectively. Suppose that a line L with slope m makes x-intercept d, then we have equation of line L is given by y is equal to m into x minus d. We need to find the equation of a line whose slope, that is m, is equal to 1 upon 2 and y-intercept, that is c, is equal to minus 5 upon 4. The required equation of the line is given by y equal to m, that is 1 upon 2 into x plus c, that is plus minus 5 upon 4. So from here we get 2x minus 4y minus 5 is equal to 0 is the required equation of the line. Next is the intercept form. Suppose a line L makes x-intercept A and y-intercept B on the axis. So the equation of a line making intercepts A and B on x-axis and y-axis respectively is given by x upon A plus y upon B equal to 1. Let's try and find out the equation of a line which makes intercept 2 on the x-axis, that is we have A is equal to 2, and intercept minus 3 on the y-axis, that is we have B is equal to minus 3. Then the required equation of the line is given by x upon A plus y upon B equal to 1. That is, we get 3x minus 2y minus 6 equal to 0 is the required equation of the line. Next we discuss normal form of the equation of a line. We have a non-vertical line, and suppose that we are given the length of the perpendicular, or we can say normal, from origin to this line and angle which the normal makes with the positive direction of x-axis. Then the equation of line having normal distance P from the origin and angle omega, which the normal makes with the positive direction of x-axis is given by x into cos omega plus y into sin omega equal to p. Let's try and find the equation of a line whose perpendicular distance from the origin is given by p equal to 5 and the angle between the positive direction of the x-axis and the normal is 30 degrees, that is omega is 30 degrees. Then the required equation of the line is given by x into cos 30 degrees plus y into sin 30 degrees is equal to 5. Now we know that cos 30 degrees is root 3 upon 2. So we get x into root 3 upon 2 plus y into sin 30 degrees is 1 upon 2 equal to 5. Thus, the equation of the line is root 3x plus y minus 10 equal to 0. This completes the session. Hope you have understood the various forms of the equation of a line.